Well, greetings, happy coders. Today we're going to tackle a static extension problem using MATLAB version 2016. Yay! All right, so here in our problem we have two tension forces and they're held in static equilibrium with a downward force W. So we got tension here and a tension there and a downward force W. So pretty much you can see it as two forces and a third force. Okay. The best way to tackle this problem is to figure out what our knowns and unknowns are. Well, looky here, we are given all unknowns. So the good part is that we're able to create data sets for three unknowns, and we can turn those into our known variables. And those three data sets will include length D right here at the top, and it'll also include our downward force, also known as weight, and it'll also include this length right here, length AB. So we have two lengths and a downward force. Now, what does that do to help us in a statics problem? Not much at all. So before we can even tackle it, solving it by hand, we need to solve a couple things before we can even get into statics, and that will be going back to basics and going back to trigonometry. That being said, we have an obtuse triangle. If you look at this as an obtuse triangle, and at least we can assume that it is, and we can turn it into two right triangles as so, and with say this is our length given and this is our other length that's given, and those are two knowns, we can find this angle so long as we use this right triangle. And doing that, we will have to go ahead and make a fourth data set, not really a data set, but variable set of values for n, and n is going to be with the max value of this d, for instance, in our problem. Anyway, I won't get too into the trig, but the way that we solve the problem is by using trigonometry first to get our theta. After getting our theta, we're able to get into our statics problem and solve for side LAC, and with the theta get our tensions. This is all that we did in our brainstorming algorithm and solved it on paper. And then after everything was solved and made sense to us with our calculations, we went ahead and got into MATLAB. All right, so let's go into MATLAB. Now, before we can even get into solving a statics problem in MATLAB, there are some conditions that need to be met when it comes to validating our data. And those conditions include making sure that all the values in our data are positive. And we use a variety of different data sets, and we'll go through them. So by making sure that they are positive, we used a for loop right here. And so it's like also a nested for loop, so this way we can check every increment in the data, because what we have is three columns and a bunch of rows, and the columns represent the side of D, side of, and these are lengths D, lengths of LAB, and the downward force of W. So that being said, we went through every increment and nested a conditional statement that if the data is negative, then change it to its positive value component. And we did that using this function right here. After checking for that and making sure that all the negatives turned into positive, we called on those new variables, okay? And then we went ahead and checked to see if that all of the LAB side lengths of LAB are less than the side of D. So we got to make sure all of the values in our data set are for LAB corresponding to that value of D that relationship is met where those side length values are less than the D values. And we did it using this for loop with a nested if-else statement. And if there were any values that were greater than D, for example, we asked the user to go ahead and enter in a value for LAB that is less than its corresponding D value. Okay, that being said, we were able to go ahead and create a function where we can go ahead and officially solve for the statics problem by calling on a function called static fun. And over here is where we define our outputs and our inputs, and went ahead and solved for theta and used theta to solve for our tensions TAC and TAB. Okay, so when we run this whole script and also calling on to the function file using the data set where there are no errors, meaning that they're all positive numbers and that all the sides lengths of LAB are less than D, which is right here, is this first test case. When we run that, everything should go through with our plot without making any changes. And so it worked. And this is where our length LAC reaches its maximum, where both tensions are the same. So this right here, the green is our tension TAC, and the blue is our tension TAB. Okay, so I'm going to X out of this so we can go ahead and test the other data sets. I'm going to comment that out. This next data set is what we're going to test for if there are any negative values, because that's going to be one of our checks. So if we have a data set with negative values, and what I'm going to do to show and prove to you that we have negative values in our data set is just comment this out and just run this section, and I have my housekeeping commands right there. So let's go ahead and just run this section so I can show you what our values are. Just this section. Let's see if I can pull that out. Oh yeah, I didn't comment this out. Hello. There you go. Okay. It's like, what am I testing? Okay, there you go. So this is the one with negative values. So let's run the section. Okay, so right here, you see I've got negative values, and then I have negative values right here. Okay, now that you see we have some negative values, let's go ahead and run it so I can show you how it looks like after these conditions are met. Great. So everything worked, and you've seen the plot. So see right here, the negatives, and I believe there was a negative 10 and a negative 43, so it turned into positive. And I think there was like a negative here, so that's all positive. Okay, let's go to the next one. So I can comment this one out. The next one is going to be the one where we have LAB values that are greater than D, and remember the condition that needs to be met that the LAB values need to be less than D. So let's go ahead and run this, and I'm going to go ahead and open up the command window so you can see what happens when we run this one. Okay. So as you can see, there are values over here for LAB that are greater than its corresponding D values, okay? And so we know that because from our input statement, the user is asked to enter a value for LAB to be less than 10. And so we can go ahead and start entering values, or a value less than 10, because it's showing that, hey, you have a LAB value that's corresponding to 10 that is not less than 10 yet. So I'm going to go ahead and enter like 3, and then one less than 25, which I can enter like 11, and then it works. So like our plot shows up, and so the whole thing runs. So there you go. Using our script for our data validation, everything works. And then with our plot and calling our functions where we defined and calculated for theta and tensions, that works too. So that being said, if I were to make any changes to this problem or to try to make it more efficient, like in the future, I would probably create a data set to check for decimals, for example. So if I had a data set with like decimal numbers, then I would probably put in like a third loop and change out any decimal values and turn them into a corresponding whole number. So those are like some things like I could do like in the future if I was trying to be more specific in solving a statics problem or any other problem. Having different conditions met, not knowing like what kind of data you get, like say you're working on a project as an engineer and you're given all sorts of data sets, it would be great to just check on all the increments given a variety of data, and the best way to do it would be through MATLAB, for example, so you can just, quickly go through all the iterations, make sure your data values meet your conditions, and then you can go ahead and solve all the problems that you need to. So that would be something that I would definitely change in the future when I'm trying to solve a problem just like this one. So I hope you enjoyed this mini tutorial, and I hope I didn't go over time. It was great doing this, and the project was a lot of fun.